back to Global Education Zone, and in this episode we are going to be dealing with a topic known as permutations and combinations. Now, permutation and combinations, they are a very important part of mathematics, because permutation and combinations involves a part of aspects where we look for the different ways in which a particular thing can happen. And I would say permutation and combination, it helps us in probability, because we often apply principles of permutation and combinations in probability. Like, I would say probability is like kind of like a grassroots of making decisions in mathematics and statistics. Then permutation and probability and combination gives us a higher level of decision making and ideas. So basically, in permutation, all you need to do is consider that permutation is basically a number of ways in which you can combine a particular occurrence. So, for example, if we have 5 people sitting on a chair, 1, 2, 3, 4, 5. Now, can you guess how many ways they can sit on that chair? So basically, you will say you might not it might not be a very common real life experience, but you often see the case where people sit in different chairs and there are different arrangements of people. So one way you can see, if there are 5 people, people one, person two, person three, person four, and person five. That means this person one could sit here, and if he sits here, that means the remaining people can sit in the 4 seats. In how many ways? So they can actually sit in 4 ways. Yes, you are correct. Because these two, okay, rather this person one can sit in 5 different seats. So, but once he has taken his seat, there are 4 seats left behind for the rest. So the first way he could sit in 5 ways, then multiply, because in permutations we only use multiplications to combine our different events. So 5 times. Then once you are seated on one seat, then you have 4 seats left, and then you have the second person can sit here in 4 different ways. That's 4. So the reason why we are taking them one by one is because 2 people cannot sit on one seat, so each of them has to sit a seat at a time. So that's why we're taking them one by one. Then we have the third person has to sit in 3 different possible seats to sit. That's times 3 times. The fourth person has 2 different ways to sit. That's times 2. And then the fifth person has only one seat, one possible seat. That's 1. So at the end of the day, we have this expression here: 5 times 4 times 3 times 2 times 1. Now, these in permutations and combinations, we represent this with a special notation. Now, that special notation is we'll just take the largest number in this product. That's 5, and then we'll put an exclamation mark. So call it 5 factorial. So this is symbol for 5 factorial, 5 factorial, and this factorial means 5 times 4 times 3 times 3 times 2 times 1. So in simple terms, I want to talk about permutations. Permutations and combinations, they utilize this concept of factorials, but in permutation, we use a special formula for it. So we use the formula NPR. So basically, this simply means that, for example, if we have 5 different seats here, and instead of arranging 5 people, we want to arrange only 3 people here. So we have 5 different seats, and we're arranging only 3 people. So you agree with me that yes, it will become kind of like a confusing place, but it's not so confusing, because the first person can sit in 5 ways. That's 5 times. The second person can sit in 4 different ways. That's 4. The third person can sit in 3 ways. That's 3. That will be 5 times 4 times 3. That's the solution of this question. Now there's a way we can represent it in mathematical notation, and that is 5p3, 5 permutation 3. So we are basically selecting 3 people out of 5, and we're going to check how many ways you can perform the event. That is how permutation works. That's a simple basis. I hope you understand that. Now we also have the concept of combination. In when we talk about combination, we are dealing with kind of C. So that's 5C and 3. Now what the difference between permutation and combination is that in permutations you are taking the order into consideration. For example, if you start from the third person, it's different from the case where you start from the fifth person and start counting. So, but in combination, you don't take regards for the number of the arrangement, the order of people, rather the order of in which they come. But is you only take consideration of the individuals or elements which are being combined, not the order in which they are combined. So in this combination, we make use of this special notation. Now let me give you the special formula for permutations. Now for permutations, NPR, which is for example 5 permutation 3, that will be equals to 5 factorial all over 3 factorial all over 5 minus 3 factorial, rather, all over 5 minus 3 factorial. So it doesn't matter what these numbers are. If it is 7, we replace it by 7. If it is any number, so but this is simply this first number's factorial divided by the difference of the factorial of the difference of the two numbers. Then we also have for the combination, we have 5 seated, that will be 5 factorial over 5 minus 3 factorial, and 5 minus 3. So rather, this factorial is outside. 5 minus 3 factorial and 3 factorial. So I hope you understand that concept. 5 minus 3 factorial and 3 factorial. So in this case, it is quite I hope it is quite explanatory enough. So basically, let's move on to this concept of questions. Let me give you a particular question, but you should understand that there are different cases where we can deal with these permutations and combinations. So let me give a very advanced question where we might need to understand the concept and how these things work. So this first question we'll be dealing with is we are told that 4 couples are seated on a bench. Find number of ways a particular couple must sit together or not sit together. So this is one aspect of permutation and combination that might be a little bit advanced for you guys to understand. So first of all, we have, they said 4 couples are seated on the bench, right? So we are finding the number of ways that a particular couple must, number 1, sit together or not sit together. So first of all, we have 4 couples, right? So these 4 couples, they must sit. In the first place, they have to sit together. Now we have, let's have them as 4 nodes, 1, 2, 3, 4. Now these 4 nodes, if we want them to sit together, let's assume these are the couples. Now these couples, they must sit together. So they must be each at the side of each other. Now in this case, there are different places they can stay. Now since they are together, let's consider them, let's compound them into a single entity. So that means they are one here. So we have them as one. Since they have to be together, then we have the remaining 2 separate. Now the actual way we are going to do this, we are going to arrange them in between themselves, and then we are going to multiply by the number of arrangements of the entire set of actual people. So in this case, we arrange these 2 in themselves. That will be 2 factorials, obviously, then multiplied by the number of ways of arranging the actual number of separate entities. So these couples, they are no longer separate because they must sit together, right? So we consider them as a conjoint, and they become one. So that means the actual number of people here, instead of 4, we actually have 3 now, 3 separate entities. So the actual number of ways of combining those 3 separate entities is 3 factorials, and that will be 2 factorial times 3 factorial. That's 2 times 3 times 2 times 1. That's equals to 12 ways. So there are 12 ways. The answer of this question is 12 ways. Now, this was for them to sit together. Now, you will say the number of ways for them not to sit together. Now, there are 2 ways of addressing this question. Now, first of all, we have the complement method, and then the second method, we have the theoretical method. Now, for the complement method, we are going to be dealing with it in this way. For the complement method, we will deal with it as, basically, we are going to look for the ways of arranging them with no restriction, and then we are going to subtract the number of ways of arranging them with the restriction to get the other answer. So this restriction was that they should sit together now. So we are looking for how can we arrange them if we don't want them to sit together, right? That means we are going to look for the number of ways of arranging 4 people. That will be 4 factorial. Then that's 4 factorial minus the number of ways of arranging them with the restriction. That's, in this case, that was 12. That's 4 factorial minus 12. So if we don't want them to sit together, we must do something like this. 4 factorial, that's 4 times 3 times 2 times 1, then minus 12. That's 4 times 3, 12. 12 times 2, 24. 24 minus 12. That will be 12 ways. So if we don't want them to sit together, we still arrange them in 2 ways. And another way of solving this question is using another method, which we call the theoretical approach. Now, in this case, we don't want them to sit together, right? So they have to be separate. So in the other ways, these other people, they are assuming these are the main people without the couples being around. These are the other people. Okay, I guess the marker is quite it's glowing faint. So we in second case, we don't want them to sit together. So we have this and this. So now there are different places that these couples can occupy. They can occupy this place. They can occupy here in between them, and then they can occupy this table. So they'll be separated by the other 2 people. So in this case, when the first couple comes here, he can occupy these places in 3 ways. 3 times. The next couple can occupy in 2 ways times 2. Then at the end of the day, we can actually arrange them 3 times to 6. These 2 other people can be arranged in 2 ways. That's times 2. So that's 3 times 2 times 2. That also gives us 12. So at the end of the day, we'll still have 12 ways. So you can decide to use the theoretical approach, or you can decide to use the complement approach. So I hope you understand this concept. This is basically it. This any other question you might see in permutation and combination will involve one or more of these concepts I've introduced in this video. Thanks for watching.